It's my pleasure to introduce Baptiste Bihan, who's going to be talking to us about the landscape problem and the multiverse.
Thank you very much. And thanks a lot to the organizers for this great event. So what I'm going to talk about is a bit more philosophical, less technical than the two talks we just had, but hopefully will be interesting for most of you. So it's a joint project with James Reed, and what I want to talk about is about this idea of multiverse, because several approaches in physics seem to claim that there is something like a plurality of universes. I mean, of course, it's a very contentious claim, but you can find this kind of claim in many places. For instance, in one approach to quantum gravity with string theory, in a particular approach to quantum mechanics with the many-world approach, or in cosmology with eternal inflation and many other models. So a general problem is, well, could we really learn from physics that we inhabit a multiverse? How serious should we be about this idea? And what I want to do today is to focus on this problem through a particular angle, namely the landscape problem in string theory. And the first thing I want to argue for today is that, well, this question being whether there actually is a landscape problem. And second, whether the existence, I want to claim that still, nonetheless, the existence of a multiverse might be a scientific claim. Alright, so let's start with the landscape problem. So string theory is consistent with a vast range of solutions, and the theory can be used to derive, depending upon the input geometrical assumptions that one makes, a vast range of different quantum field theories, giving rise to the so-called landscape problem. So here the landscape is a space of solutions, no story about other universes yet. And interestingly, while string theorists were initially expecting string theory to have only one solution, that was an old hope, to quote Keiso Matsubara. But then this view has been supplanted by the landscape view that string theory will probably end up having many solutions, a huge number of solutions. And so at first glance, what we could say is that in a way the nostalgia of the old hope of getting one solution only from string theory has motivated theories to reify the landscape into one multiverse. But wait, if we present things like that, seems a bit weird, right? Because what about the general theory of relativity? GR seems to have, well, it has many solutions that do not correspond to the actual world. It's not usually regarded as being an issue for general relativity. So here is a quote from Michael Green. This supposed problem with a theory having many solutions has never been a problem before in science. There is a landscape of solution to general relativity, yet nobody says that the theory is nonsense, because only a few of them describe the physics we observe, while the rest appear to be irrelevant. So why is the existence of many solutions taken to be a particular issue in the context of string theory, when it's not in the context of general relativity? Well, this difference of reaction might take its roots in the largely accepted view that our current most fundamental theories at the moment in physics are not absolutely fundamental. GR has many solutions, and it's not a problem because GR is not a fundamental theory. There is Lee Smolin. What to say about this is what follows. Why does general relativity so extravagantly overperform its job, giving not just predictions for the actual universe, but also for predictions for an infinite number of universes that never exist? The only conclusion to draw is that general relativity is not the correct cosmological theory. So it's interesting to see here that there is this idea that an absolutely fundamental theory, a final theory, should just have one solution. So I want to discuss several issues. So first, here are two potential issues one might perhaps a bit naively raise against this existence of a landscape of solutions. First, the landscape problem undermines the predictive power of string theory. Second, the landscape problem undermines the explanatory power of string theory. So let's have a look first at the predictive power of string theory. Well, what do we mean exactly by that, by predictive power? Well, the idea is that given the empirical data observed thus far, we are able to identify at least one solution of the theory in question, compatible with that empirical data. And such solutions can then be used to make new predictions that could turn out, but do not have to be correct. On this understanding, the total number of solutions of the theory under consideration is irrelevant to the predictive capacity of that theory. What is relevant is the number of solutions of the theory which are compatible with the empirical data gathered thus far. So what matters is whether that theory can be used to make further predictions in the actual world. And the landscape does not per se speak against this problem of predictive power. And in fact, given the dearth of models of string theory compatible with the standard model, right, you have to find one, the risk for string theory is to be potentially falsified rather than to be unfalsifiable, which is a good thing for scientific theory. So what about the explanatory power of string theory? So is there anything problematic with string theory when it comes to its capacity to explain things? Well, here I think it's really important to distinguish between two things. First, there are situations where you can use the more fundamental theory to explain some features of derivative theory. Like when you want to explain, for instance, proportionality of gravitational mass, inertial mass in Newtonian physics by using GR. And then it's a completely different thing to want to explain all the features of a fundamental theory, right? Then it's something else that you want to do, is to give an explanation, an ultimate explanation of all the features of the more fundamental theory. So here I think it's really important to notice that because we may not give an explanation of all the features of string theory, while it does not follow that string theory is not explanatory. Right? So from this idea of a landscape of solutions, I don't believe there is something really problematic with string theory. It's predictive and has explanatory power. So the landscape problem is not a genuine problem, at least yet, when we have just said that. And so the landscape of solutions of string theory, taken alone, should not motivate us to posit the existence of a multiverse. So now I want to introduce this idea of a multiverse, to make a few considerations about that, to then come back to what I just said. So this idea of a multiverse, basically you take all the solutions of your previous theory, you reify them, you say that there is a universe associated with each of the solutions, and you say that, well, we live in a multiverse comprised of all those universes composing the multiverse. So here is the first question: is there something new with respect to predictive power when moving from the landscape to the multiverse? Well, arguably no. Because insofar as string theory itself can be predictive, so too can string theory embedded in this multiverse. Again, what matters here is whether that theory can be used to make further predictions in our universe. And the existence of other universes doesn't really matter. Thus, the multiverse doesn't pose a special problem when it comes to the issue of falsifiability. But then, what's the motivation from string theory to posit the existence of a multiverse? If there is no issue of predictability with string theory without a multiverse, why are many, or at least some physicists, willing to posit the existence of a multiverse? Well, I guess one strong motivation is that it's supposed to augment the explanatory power of the framework. And indeed, I want to start talking about rationalism and to introduce a few more abstract points about the motivations you can find in the beliefs of people working on quantum gravity. String theory is often regarded not only as a theory of quantum gravity, but also as the final theory of everything. And the final theory is supposed to be absolutely fundamental in the sense that there should be nothing left to explain, at least in some sense. It's one way to characterize this finality claim, at least about the physical world. And Smolin believes that if an absolutely fundamental theory has more than one non-trivial solution, we need an explanation for why our actual world corresponds to a particular solution of the landscape. Right, so here you have this idea of finality. If you have a final theory, you want to explain why this solution rather than another solution. But why exactly should we believe this? Well, so Smolin's reason is that he believes in something extremely powerful, but also extremely question-begging. This is the principle of sufficient reason, or at least he mentioned his motivations. These were in the paper. And roughly the idea is that everything must have an explanation, a reason for why it is as it is. So here is a quote from Smolin. I bring up Leibniz's principle of sufficient reason because I believe it helps greatly to clarify the issues that we confront in seeking a solution to the landscape problem. In particular, the principle of sufficient reason not only tells us that laws must evolve to be explained and that there must be a dynamical explanation for the initial conditions of the universe. It greatly constrains the context in which we fix those dynamical explanations, which led to the selection of the laws and initial conditions of our universe. So, yes, so you have this idea of explaining a lot of things. And Smolin is explicit that he wants to explain some fundamental facts. First, you want to explain the form of the effective laws of nature. Namely, the idea that we have one set of laws, a bubble universe in the multiverse, represented by some deeper theory. You also want to explain the parameter values in those effective series by appeal, for instance, to some geometries, string theory geometries, associated with each bubble universe. And you want also to explain the various possible initial conditions by embedding each model of one theory with its own initial conditions into one model of a multiverse theory.
Excuse me.
Yeah.
Sorry to interrupt, but there's something I'm simply not following. Whenever you explain something, you explain in terms of something else.
Yeah.
There is no possibility of explaining something without departing from somewhere. So what is this program of explaining everything?
Okay, I'm going to go to get to that. That's the next part. But I'm happy to get back to you if you're not satisfied. So what I just want to say here is that clearly these reasons to embrace a multiverse are not directly related to the need to account for the empirical data in the actual world. There's something a bit more rational going on here. And what I want to notice here is that for Smolin, explanation goes far beyond explaining states of some systems in reference to dynamical laws and initial conditions. Here's another quote from him. So it was not in the final version of the paper, it's in the preprint version. Maybe for the kind of reasons that you just mentioned. He writes, if the M theory is to be the real theory of everything, it must be formulated in such a way that we cannot further inquire as to why these laws and why these initial conditions. It must somehow furnish its own sufficient reason. So it's still some kind of idea in the back of, it's not in the final paper, but you have many hints of this kind of ideas in the paper. So it's certainly true that the principle of sufficient reason acts as a useful guiding principle in theory construction. I won't be denying that, and of course we should accept this idea and try to find causes and reason to make progress in science. But there may be some problems when you want to apply in a very universal way this principle of sufficient reason. And the first issue regards Smolin's claim that dynamical laws and initial conditions should be explained. So he says that laws must evolve in order to explain. So he thinks that we need some kind of temporal explanation of laws. And also thinks that initial conditions should be explained with some kind of anthropic reasoning, or in this case, a kind of temporal explanation with a cosmological selection principle. But this, let's start with the laws first. This claim that laws must evolve in order to be explained is highly problematic. In fact, it seems to disregard much of the literature on the ontology of laws of nature. You find the literature, the philosophical literature, because there you find many accounts to explain what are laws of nature of a different, more philosophical sort. For instance, by saying that laws are just regularities, or by identifying laws as abstract second-order relations connecting first-order properties, or with disposition. I mean, you have many different accounts, and all of them are explanations of laws of nature. And they are not really scientific explanation, and they are not temporal explanation. But still, it's a bit problematic to say that in order to explain laws, we need to provide some kind of historical scenario. And furthermore, the possible emergence of space-time from a non-spatial temporal structure in quantum gravity kind of shed doubt on this idea that all non-logical, I mean, not only logical, scientific explanations should involve time. It seems like a very strong claim to mention that all scientific explanations should involve time. And finally, well, it's also a rationalist assumption that laws, including their forms and their parameter values, should be explained to begin with. Again, it seems like a healthy guiding principle to try to explain that. But something else to say that it must be like that. They must have a reason. What about explaining the initial conditions of the universe? Well, again, you can use some kind of anthropic principle or the cosmological selection principle to give an explanation of those initial conditions. And again, I want to praise that again. It's of course very interesting guiding principles that we should use. But claiming that the cosmological initial conditions must have an explanation is a very strong claim. And to me it seems to kind of overgeneralize the scientific practice. Yes?
Just a quick question. What do you mean by cosmological selection principle?
I was thinking about Smolin's idea that there is some kind of evolution of effective field theories, some kind of selection principle in comparison to the case in biology with a theory of evolution. So I was having in mind Smolin's picture of that. Yeah, so this idea of explaining initial conditions, I mean, the very distinction between initial conditions and laws, it seems that something that we use all the time in many contexts, but it's not that trivial to say that it can be generalized to cosmological level, and that it makes sense to try to explain the universe like that. So I want to now raise another issue with this idea.
Sorry to interrupt. If the cosmological selection principle is like Smolin's one, and it's analogous to a natural selection principle, like in Darwin's natural evolution, how can it explain the initial conditions? It's rather the other way around. It's a principle that almost tells you that it doesn't really matter what the initial conditions were. The evolution of the system, or the set of systems, the species, has a certain rule for keeping alive some possibilities and removing the others. So it may explain the current state as the most likely, but doesn't really say anything about the initial conditions. In a sense, it makes it irrelevant.
But I guess it depends on what you mean by the...
Then, unless I guess I'm not understanding in what sense you're talking about initial conditions.
Here I think about the
selections.
cosmological initial conditions of our universe. And you can give an explanation for why it's very probable to be very likely. Very likely to be in one universe with those parameters, with those apparent initial conditions at the beginning of the universe, because you have some evolutions of the parameters. So it's how I will understand this idea that it explains the apparent cosmological initial conditions of the actual universe in which we are. I think it's what he says in the paper. Yeah, so coming back to this idea of everything must have a reason, right? Another problem is that, well, of course, there were a lot of past successes using the principle of sufficient reason, and again, it's a very useful guiding principle, but is it really enough to think that as a matter of necessity, it has to always work in any context? It seems that from a purely empirical perspective, here we have some kind of a leap of faith if we think that it must universally apply in any context about anything. But what about a more rationalist perspective? Could we argue a priori that the principle of sufficient reason universally applies, that everything must have a reason? So if you look at the debates in metaphysics, it's interesting to see that this principle used to be rejected in the 80s until 2000 because of some arguments given by von Inwagen and Bennett. So I don't really want to discuss the details of these arguments, but just to give you a feel, it's the kind of arguments that go like this. If you take the list of all the contingent facts composing the world, the totality of this fact is itself a fact, and you want to ask, does this fact has an explanation? And you want to say yes, because everything must have a reason, so it must be an explanation for this fact. But no, if this fact is itself contingent, it means it's already part of the list of facts, so it must explain itself, which has been thought to be a bit problematic. And if it's a necessary fact, people think that it entails that all the previously thought contingent facts are in fact necessary, and so everything becomes necessary. So this argument is not accepted anymore, because people have criticized many assumptions there. But it's just really to give you a feel of what it could mean to argue for the PSR on purely a priori grounds without referring to physics. So as I said, this argument was shown to be inclusive, and there is a revival because of this. But it's not because this argument is thought to be incorrect now that there is a conclusive, a priori argument in favor of the PSR. So again, I think in fact, if you think about it, this idea of an a priori argument backing the PSR, well, again, it requires a leap of faith, because you have to accept that it's possible to settle a priori whether or not everything can be explained. And to me it seems a bit obvious, at least if you have a more empiricist perspective. So both the principle of sufficient reason and the idea that we can discover a priori whether the PSR is correct or not rely on some faith in some sort of rationalism. So now maybe I think, but what do I mean exactly by that? So here is what I mean by rationalism, is the view that reason is absolutely powerful and can in principle explain everything about the most generic aspects of the world with science. And it stands in opposition to empiricism, the view that anything which is not subject to empirical testing, or at least strongly suggested by empirical science, is question-begging, when taken as being more than just a guiding principle in theory construction. So again, seeking to explain cosmological initial conditions and laws of nature is fine as a guiding principle. But there must be good empirical reason to believe that there must be a reason for why they are as they are. So there is a landscape problem only if one accepts rationalist motivations. And then only one may be tempted to move from the landscape problem to the existence of a multiverse. So now I'm done with this part, and what I want to do is to just make a few remarks about how it could maybe relate to eternal inflation and cosmology. It's still very sketchy. I don't really have time to explore in detail this literature, so we'll just make a few points. So we start by this quote from Yasunori Nomura. The eternal inflation picture is obtained by just using general relativity, and all this energy scale associated with this process is much smaller than the Planck scale, where we believe that the theory is correct. The only aspect you need for this particular purpose from string theory is a lot of different vacuum, a lot of different universes, where the vacuum energy is different. As long as that aspect stays in whatever theory of quantum gravity, then that's enough to keep this picture. So it's just to say that, I mean, there is much debate about the relationship between string theory and internal inflation. Here this quote shows that there is no necessary connection between string theory. So eternal inflation does not stand and fall with string theory. So it also means that the eternal inflation multiverse does not stand and fall with string theory. Rather, string theory offers a convenient theoretical tool to make sense of the creation of universes in the background of eternal inflation. So as long as the theory, as the vacuum energy remains the parameter of one theory of quantum gravity, well, eternal inflation is fine. So what's really important here, I think, is that the move from the landscape of solutions to a multiverse might be justified externally by eternal inflation and its associated empirical signatures, but it doesn't seem to support string theory in particular. So here there is what I wanted to say is that although we don't have motivations from string theory alone to accept the existence of a multiverse, maybe we could have more empiricist motivations coming from a cosmological model, but it's a different line of justification. So should we be impressed by the fact that both string theory and eternal inflation suggest the existence of a multiverse? Well, I guess it depends on how strong the suggestion is, right? And how strong the justification of string theory and eternal inflation is. So I suspect here again, it would be healthy to be a bit skeptic about the rationalist motivations in the context of eternal inflation. But as I just said, maybe there are more empiricist motivations to take seriously the idea of a multiverse in cosmology. So you have many scenarios, like with Penrose conformal, cyclic conformal cosmology, or this idea of collisions between double universes. I've read that there are some predictions of a small negative curvature from eternal inflation, that it's hard to distinguish it from vanishing curvature. But there are some attempts to find some empirical signatures of those models. So now I want also to mention that I'm aware that some issues about eternal inflation, like that we can only dismiss models and not the theory as a whole. Sorry, Chris Mink mentioned talking about this high flexibility of the framework, and that's a problem. Given a fixed choice for the inflaton field, discrepancies with observations will force theorists to elaborate the model, possibly identifying new features of the early universe in the process. At present, the choice of inflationary models is too flexible to support this kind of approach. So I'm aware that there is a measure problem. So, and there is a predictability crisis there. But first, it seems that well, we could still make some scientific progress by narrowing the space of possible solutions. And second, maybe by combining quantum gravity with eternal inflation, we might get enough constraints to really shrink down the space of solution and make it more predictive. So at least there are some hopes that it could be, in principle, possible to do. All right, and before, just to conclude, just a few notes about some more philosophical multiverses. As some of you know, you have probably two main philosophical multiverses in a very broad sense of a multiverse. You have David Lewis' model realism, that any possible world exists. And you have Max Tegmark's mathematical universe hypothesis, like all the mathematical structures exist. Well, just to comment on that with respect to the distinction I introduced between rationalist and empiricist motivations. So of course, the philosophical multiverse seem to be motivated only by rationalist a priori motivations and not really by science. However, I think it's interesting to remember that there might be some empirical constraints that we might learn through physics that could have an impact on how plausible those philosophical views are. So for instance, Christian Buttress has a paper where he argues that model realism is in tension with the potential emergence of space-time. So it might count as some kind of, if it were to be confirmed that space-time emerged from a non-special temporal structure, modern realism, as introduced by David Lewis, will collapse because he needs this idea of possible world being spatio-temporally disconnected. So he really needs this idea of space-time being fundamental. So if you lose this, well then you cannot really have his philosophical view of model realism. So it doesn't mean that I'm saying that because it might be ruled out.
Sorry, I missed the point where it needed to be connected. Why are these multiple universes needed to be connected? I mean, I thought you argued that this emergence of space-time requires these entities to be disconnected, and somehow that negates the possibility of them all existing. Why is the connected part needed?
So it's because it's how David Lewis make a distinction between what's actual and what's only possible. So he used a criterion of causal / spatio-temporal connectivity. He said that one world is everything which is spatio-temporally connected, and everything which is not spatio-temporally connected to our world is not our world, it's another world. So it's just the way he defined things, and you need to define this for philosophical reasons. But there is a tension with this idea that space-time might emerge and not be fundamental. Because in his view, he really needs this fundamentality of spatio-temporal connection and spatio-temporal disconnection. So, yeah, so I don't want to say that David Lewis model realism is scientific because it could be ruled out on scientific ground, but still I think it's interesting to see that some metaphysical claims that might seem out of empirical reach in some situations can in fact turn out to be. And as a result, I think we should be a bit skeptic to some degree about our capacity to know what lies out of empirical reach in general as a matter of principle. It's also a way to be a bit careful when we think that, well, maybe this multiverse idea are just too abstract and too far away from empirical testing to be interesting. I think we should be really careful about giving this kind of justifications. So, just to sum up, on the one hand, string theory having a landscape of solution is not as problematic as what is claimed in the literature. The inference from a landscape of solutions to the existence of a multiverse can be made sound if one accepts rationalist claims that we need to explain the parameters involved in the field theories, that we must explain the initial conditions. But those rationalist claims are difficult to justify because they rely on this idea, on this principle of sufficient reason, and there is a leap of faith there to think that the universal applies to everything. On the other hand, multiverses models are scientific if they have an empirical signature in a broad sense. So, empiricists should consider seriously, according to me, multiverse scenarios, since such models cannot be dismissed as unscientific, on purely a priori grounds. Thank you very much.
We have just over 20 minutes for questions.
Okay. Let me first emphasize what is often mixed in, especially in philosophical discussion. Let's make a very strong. Let's the raw line between multiverses in the narrow sense, which arise as a consequences of practically all inflationary models, and multiverses in much general and much more speculative sense, which follows from the string theory. In inflationary models, indeed, we have it's a generic prediction, practically in all models, which where they showed that the old statement that inflation explains homogeneity of the universe is a wrong statement. Okay, so it explains homogeneity only in some finite volume. And so it's generic prediction that there exists in post-inflationary universes where appears actually infinite number of parts of space-time which are no more in causal connection, more exactly which do not lie in the past and future light cone of any given observer. Okay, but physics in all of these multiverses is the same. In particular, the cosmological constant is the same and equal to the observed one. It's a completely independent speculation, okay, hypothesis of the string theory that it might be many other models, but once more, it's at this level, it's only a speculation. And once more, returning to the multiverses in the narrow sense, I would say it's nothing unscientific. And what I want to emphasize is essentially the same picture which we have in the usual Einstein gravity. We are sure that there exist many black holes in our universe. We actually see them, and interior parts of these different black holes are outside past light cones of any given observer. So, and nobody said that it's unscientific to investigate what happens inside black holes. So in that sense, it is multiverse once more in the narrow sense, which follows from inflationary models is no more unscientific. But as I said, investigations of integral of different black holes.
Thank you very much.
The person.
Okay, thank you very much. Yeah, I definitely agree with what you said. Except Paris when you said that no one thinks that they are unscientific. I mean, find many different opinions, right, in the physics community. But I mean, what I was trying to do is just to gesture toward a bad way to be willing to justify the existence of a multiverse with this landscape problem. I think that we must explain many things. I mean, it's an interesting guiding principle, and maybe can relate to other parts of physics and become externally justified. But still, we should just be careful about putting too much trust in rationalist principles, such as the principle of sufficient reason. Because, yeah, that's what I was trying to.
What when my final comment went, okay, I will say that as far as we work, my impression that rationalist principle is working. What's more, of course, if we don't pretend that we understand everything, okay, but as far as we explain one thing, as you said, using other thing, more exactly if we find some new empirical fundamental constant and we express it through known fundamental constants, okay? It works as far it works.
Okay.
So I'm curious about one kind of motivation for reifying the multiverse that I think comes up in some of the literature that you didn't mention. So I think there's a general question. We reason in science all the time with spaces of possible models, and so why would you take those as being actually existing elements of an ensemble? And I think sometimes people are motivated by the idea that, and I'm not endorsing this, but that if you think of a selection from elements of an ensemble, that you can give a different kind of account of that if it's an actually existing ensemble. So that you can say, how do we, why do we see what we see? Well, we're anthropically selected from an actually existing ensemble of possible universes. And I think that's actually one motivation for some of the string theory landscape discussions, to take the landscape as actually existing parts of, or actually existing elements of an ensemble. But then you can motivate, you can appeal to this sort of selection reasoning. So again, I'm not endorsing that, but I'm just wondering, because you mentioned early on it's not clear why they reify these different solutions, and I think that's one motivation I've seen.
Yeah, that's why I might want to mention the entropic principle. Yeah, I think it's. I agree. It's a prima facie appealing way to think about things, but then if you want to balance that with another scenario in which you just have a brute fact that we happen to live in this world corresponding to one dynamical solution, how are you going to choose? I mean, it seems to me that if you want to choose for the former scenarios, then you need some kind of rationalist principles that you cannot discover and you can really relate to the empirical world.
Is that a finger? Go ahead.
You pointed to me afterwards.
Go ahead.
Okay, probably it's connected to your comment right now, but also to your initial talk. If I understand correctly, this lack of models, of concrete realizations of string theory that may fit with our observed universe, with the known facts of our universe, may be taken as a strong indication, and here I'm speculating, that perhaps the set of possible solutions to the string theory that are compatible with our universe may be of measure zero. And in that case, as an act of desperation, I think, you would be tempted to adopt the multiverse as the only possible escape, using then the argument, okay, it's true, it's of measure zero, but actually all of them are real. And of course we happen to be in the one that is compatible with humans and so forth. So I would see that as an act of desperation by somebody extremely attached to string theory, if it turns out that the problem they are having in finding solutions indicates, you know, zero measure of possible solutions.
Yeah, thanks. Thank you, I agree. Very interesting.
Ken?
Yeah, thanks. Earlier in the talk, you cited Carroll, and you said something to the effect of, you know, one of the reasons why you might think these multiverse hypothesis is a scientific hypothesis because it narrows the space of possibility. I guess I'm curious, could you be a little bit more specific about what you mean by that?
I mean, I guess.
I mean, on some views of theory space, it seems to me it would expand the space of possible solutions, not narrow it. So, what do you have in mind by that?
I mean, the idea was, so you have this predictability crisis in inflation because the problem is that you can make the framework consistent with too many things. And one way to put the problem is that you cannot, seems difficult to roll out the theory on empirical ground, but you can still rule out models of the theory. And Sean Carroll in the paper is saying, well, probably it's not fully satisfying, but still it counts as some progress to rule out some models. Just,
Yeah, I have a question, but I would like to go beyond the example that you gave for multiverse and landscape. So from the point of view of yourself as belonging to philosophy, I believe, I would like to ask you, so where do you have to draw the line and say we accept certain things, we're not going to understand them? Because from our point of view, as physicists, we try to understand everything. So here is a general question. Because you know, ages ago, people could have stopped doing anything in physics, say that's how it is. I mean, the sun and the planets have this, that's how it is, I'm not trying to explain it. So, according to you, where we should draw the line and accept certain things that we can never explain. And you said at some point in your slides that to claim that we can understand everything is a big claim or something like that. So can you forget what physicists said, but from your point of view, where do you stand?
So I guess, yeah, the first thing to say is that I think we should really try to explain everything all the time, right? It's the right way to go. We should not refrain ourselves to try to explain things when we think that may be room for finding an explanation. So we have to explore all paths. But it's more like a pragmatic view, right? It's what we should do. Then it seems to me you're asking a more epistemological, maybe metaphysical question, which is, leaving this aside, could we explain in principle everything, right? That's what you're. And here I'm just a skeptic. I think that we cannot know the answer to this question. We can just know that we should not be lazy, right? We should try to always do some work to explain as much as we can. And maybe it seems reasonable to think that we could explain principle or facts. But when you start asking more abstract questions about, for instance, whether could we explain laws of nature in general, the existence of law of nature, of why they are as they are, then I think we are moving to a different level. It's far more speculative, and I don't have any answer to that. I would be tempted to be a bit skeptic about it and say, well, we'll probably never know whether everything can absolutely be explained.
Thank you. So my question, I'll address it to you, is probably posed to someone more like Smolin, who actually endorses the multiverse as an explanation for certain things. But if Smolin wishes to explain all things, presumably we still are left with an explanation of M theory or the multiverse itself. So can we ever really, so Daniel said at one point, we always explain something in terms of something else, and in this case, it's the multiverse that we're doing the explaining of our particular initial conditions. and the way things work in our universe. But then presumably Smolin will still be left with the task, if he really wants to explain all things, explaining, you know, the overarching structure. I mean, now if the overarching structure is a result of pure reason, or we can get to it through a priori reasoning, then we might think we have rational reasons for thinking it, where it's self-justifying. In one of your slides, you say, you know, somehow the conditions of explanations for M theory are going to rise from within the theory itself. And so I'm wondering, what does Smolin say about this issue, if he really wishes to explain all things?
Yeah, I definitely agree. I think that it's another line of argument you can raise against him, in a way, saying that, well, if you want to explain everything by postulating the existence of a multiverse, describing M theory, well, you will, for instance, if you take the multiverse, you still have to explain the existence of the multiverse. So you have to have more philosophical work to be done to say why there is this multiverse, and also why there is this fundamental law of nature. So I guess, yes, there is some progress made when you replace what seem to be arbitrary parameters in some laws by some space-time geometries, and you say all of them exist. You can see this as a progress in the chain of explaining everything. At some point you will have to terminate somewhere, right? I mean, it's the old Aristotelian problem of explaining the first cause, right? And I don't think there's no need to explain this.
So I think it's important to contrast Smolin with the multiverse, actually, because he wants to do something much more radical, which is introduce this idea of evolving laws in order to, in effect, have a unique solution. So he thinks of the multiverse as one sign of a crisis that leads to this more radical proposal. But I was curious, I'd like to compare your take on string theory as a possible final theory with Ricard David, who's written about the features of string theory that might give it a particular character as a candidate for a final theory. And I'm wondering if Ricard would like to comment on that, just because I know he's considered this question, and I wonder how it relates to the discussion we're having.
You mean the status of the multiverse, or the possibility to confirm it?
No, I mean about, you have a line about string theory as a final theory, a theory with no free parameters. And
right, yeah. So, I mean, I think that the understanding that a theory is final, in conjunction with other arguments that can support the theory, can increase trust in that theory. I don't think that this necessarily means that one should have a priori a very strong preference for finality. I think it's something we either find when we look at nature or we don't. So I think I would put it a little bit in between being a very strong guideline that one should follow and playing no role at all. So I would think it's somewhere in between, in the sense that if one finds indications that a theory is finite, that is relevant and that can speak in favor of the theory.
You also had a question?
I also had, yes, actually I had a question related to that, but before that maybe I would want to try and answer to Mary's question. One point one might make is that one might be convinced of not trying to explain something if one has a trusted theory that tells not to do so. So, for example, if quantum mechanics tells us that we shouldn't try to explain specific outcomes of experiments based on the initial state, then we won't try to explain because we trust the theory. So I think if something along those lines occurs down the road in connection with multiple theories or entropic reasoning or whatever, then it would be a reason to do so. And the question I had for Baptiste was related to to this idea that one wants to have a theory without final parameters with just one solution. And it seemed to me that you make that argument very strong in motivating or in supporting the hypothesis that there is a multiverse, which wouldn't quite be the impression I had. I would feel that the reason one endorses the multiverse those reasons are physics reasons based on string theory and based on what one understands about cosmic inflation. And then it comes as a nice additional advantage that it reinstalls this old goal of a theory without any freedom in choosing parameters at a fundamental level, or without being arbitrary with respect to what exists, let's say. So my question is, do you actually think that physicists try to develop multiverse theories already for that simple reason that they wanted to have it, or wouldn't it rather be the other way, that once they got the multiverse, they thought, oh, actually that's nice, on that basis we can retain that old quality we thought that was lost?
Yeah, I mean, I agree. I completely agree. I'm not sure there is one unique dialectic at play here. It probably depends on the different individuals. But yeah, I agree. It makes sense to be happy if we get an explanation of the way of the parameters and we can explain that. I would just mentioning that if you use this as a motivation for believing in the existence of a multiverse, then it's problematic. So I agree with you. I'm just mentioning that there is a particular path that we should not have. And this particular path is to say, well, there is a landscape problem, which is really the existence of many solutions. And that should be because we want a final theory having just one solution. Or just, I guess, trying to make this motivation explicit. Trying to say, well, it's not perhaps the best motivation we should have. But I agree with you that if we manage on the way to explain things with multiverse, then it's good.
Yes, that's good.
Yes. So I have a comment on this. So I don't think that the majority of physicists would say that the fact that there's a landscape implies that there's a multiverse. So you have to actually buy the various stochastic arguments. And I think there are reasons. I think the majority of string theorists would not go in that direction at the present time.
Okay. Any final questions? Okay. Then we can